Hello students, welcome back to my YouTube channel. In this video, I am going to discuss about force between two parallel current carrying conductors. When two current carrying conductors are placed some distance apart, if the current is going in the same direction, the force between them is attraction, and if the current is going in the opposite direction, the force between them is repulsion. This phenomena we will explain in this video. Okay, so we all know that current carrying conductor produces magnetic field. If it is an infinity long, the magnetic field formula is B is equal to mu 0 I by 2 pi d. And the direction of the magnetic field can be found out by using right hand thumb rule. Okay, how to apply the right hand thumb rule? Place your right hand in such a way that the thumb point the current direction, the curled fingers gives the magnetic field direction. And one more concept we need, that is, when a current carrying conductor is placed in a magnetic field, it will experience a force. That force is equal to ILB sin theta. Okay, with the help of these two concepts, we can explain this phenomenon. Okay, so first of all, I am taking two current carrying conductors of infinitely long. This is one current carrying conductor, this is infinitely long, and another current carrying conductor. This is another current carrying conductor, this is infinity. The current passing through this conductor is I2, and the current through this conductor is I1. The distance between them is D. Okay, clear? So, I am taking the case 1. In the case 1, the first current carrying conductor producing the magnetic field. In that magnetic field, the second current carrying conductor is situated. Okay, that means the first current carrying conductor is an infinitely long conductor. This current carrying conductor produces a magnetic field at here, that is AD distance. So what is the magnetic field? The magnetic field produced by the first current carrying conductor I am taken as B1. The B1 is equal to mu 0 I1 divided by 2 pi d. Okay, so this direction of the magnetic field can be found out by right hand thumb rule. So I will apply the right hand thumb rule. My thumb I am placed in the current direction, the curled fingers the magnetic field direction. So you see here it is going into, the magnetic field is going into it. So the magnetic field is like this. Okay, this is the B1 magnetic field. In this B1 magnetic field, this second current carrying conductor is situated. So when a current carrying conductor is placed in a magnetic field, it will experience a force. Okay, so the second conductor experiences a force. So force acting on first conductor by second conductor is how we will represent. Force acting on the second conductor by the first conductor. Force acting on this conductor, that is the second conductor by the first conductor, that is F21. Force is acting in which conductor? That will represent first. Force is acting on here I2, so F2. Who is acting? I1 is acting. How I1 is experiencing a force? Producing the magnetic field. That F21 is equal to ILB. So here I am consider an L length portion. This is the L length of the conductor. I am finding in this conductor, in the I2 conductor, L length portion, how much is the force is experienced. So here the force is experienced from which conductor? The second conductor. So the current is to be I2. Okay, and the length is to be L, and the magnetic field is what? this I2 conductor is placed in the B1 magnetic field. So here we can write it as B1. So what about F21? F21 is equal to I2 into L into B1 value. That is mu 0 I1 divided by 2 pi d. This we can write it as mu 0 I1 I2 divided by 2 pi d into L. This is the force acting on the second conductor by the first conductor. Okay, what is the direction of this force? This force direction can be found out by using Fleming's left hand rule or right hand rule. Okay, how will you apply the right hand rule? Place your right hand in the direction of current and curl towards the magnetic field direction like this. So I place my right hand in the direction of current, curl towards it. So I will get the magnetic field direction is like this. Sorry, magnetic force direction is like this. This is the force acting on the second conductor. Okay, clear? Okay, then now I am to be discuss the second case. So this force is to be an attractive towards I1. Clear? Okay. Now I will discuss the second case. Clear? Okay. Second case we have to discuss it. For that I am to be consider this, or I will be erase it. Okay, clear? Now we will see case 1. Sorry, case 2. So now we will assume that the second conductor, the I2, is producing a magnetic field. This is an infinitely long conductor. The magnetic field produced by this I2 conductor is B2, that is equal to mu 0 I2 divided by 2 pi d. And what is the direction? The direction can be found out by right hand thumb rule. I place my thumb in the direction of current and the curled finger. That is, it is going into it. Here it is coming out. So you see this? The magnetic field is coming out. Magnetic field is to be coming out here. Magnetic field is to be coming out. Okay? Clear? So this is the which magnetic field? That is the magnetic field B2. Clear? Okay? In this B2 magnetic field, this I1 conductor is situated. So this I1 conductor will experience a force. That force is force acting on first conductor by the second conductor. Force is acting on the first conductor. Okay, by second conductor. How the second conductor experience a force on the first conductor? The second conductor produces a magnetic field. That magnetic field experience a force. Clear? So force acting on first conductor. So we will write it as first. Okay? F2, F12. That is equal to ILB. Okay? Here force acting on first conductor. So I1. And the magnetic field is produced by the second conductor, so that is B2. What about F12? That is equal to I1 into L into B2 value, mu 0 I2 divided by 2 pi d. So what you will get here? F12 is equal to mu 0 I1 I2 divided by 2 pi d into L. Okay, what about the F12 direction? The direction can be found out by right hand thumb rule or Fleming's left hand rule. Okay, I am going to apply a right hand rule. So I place my right hand in the direction of current, then I curl my fingers in the direction of magnetic field, that is like this. Place like this, like this. So I get the force direction is like this. So this is the force direction, F12. That is, F12 is acting towards I2. towards I2. Okay. So what you can see that F12 is equal to minus F21. Why? Because these two forces are acting in the opposite direction. We already got it as F21 is like this, F21 is like this. Okay, these two forces are acting in the opposite direction but the same magnitude. Okay, so what about the force per unit length? Force per unit length between two conductors, two current carrying conductor is mu 0 I1 I2 divided by 2 pi d. This is to be the value. Okay, so if two current carrying conductors are placed d distance apart, the force per unit length is mu 0 I1 I2 by 2 pi d. If the current is going in the same direction, it will be attract with each other. Now we will see when the current carrying conductors are placed some distance apart, the current is going in the opposite direction, what will be happen? Okay, first of all we are going to consider this conductor. The first conductor produces a magnetic field in the second. In which direction it will produces the magnetic field? The magnetic field is, you can see that you apply the right hand rule. So here it is going into it, here it is coming out, so here all it is coming out. Okay, this is the magnetic field. In this magnetic field, what is placed? In this magnetic field, the second conductor is to be placed. Okay, so this is a B1 value. In this, what is placed? The second conductor is placed, so the second conductor experiences force, that is F21 is equal to what? I into LB, that is L length I am taken, this is the L length, L into what is B1, this is I2. Okay, what about this direction? This direction we can find out by using right hand rule. So place your right hand in the direction of current, then the curled fingers. That means the force is acting in this direction. This is F21 force. Okay, F21 force. And next we will see the force acting on the first conductor by the second conductor. This conductor produces a magnetic field. Okay, this conductor produces a magnetic field is in which direction? Like this. It will produce a magnetic field. You see this? Here it is going into it. Okay, then it is coming out. So all of here it is like this. This is what? This is the B2. Okay, in this B2 magnetic field, I1 current carrying conductor is placed. So it will experience a force, that is I1 LB2. What is the direction of I1 LB2? That you can find out by right hand thumb rule. Okay, so if you apply the right hand thumb rule, you will get the direction of force is in this direction, F12. Okay, so you see that these two forces are acting in the opposite direction. Okay, if these two are placed d distance apart, the force per unit length is mu 0 I1 I2 by 2 pi d. Okay, the same way, but only the direction is changes. So the current is going in the same direction, the current carrying conductors attract. When the current is going in the opposite direction, current carrying conductors repel. Okay, due to this phenomena, you can see that when the electric lines are to be situated some distance apart, okay, to avoid this force, they have to be placed the electric lines some distance apart. Okay, this is about the force between two parallel current carrying conductors.